Welcome to this episode of Georgia Highlands College Chemistry Podcast. In this episode, we're going to be discussing metathesis reactions. And what is a metathesis reaction? In many reactions between two compounds in aqueous solution, the positive and negative ions appear to change partners to form two new compounds with no change in oxidation numbers. Reactions like this are called metathesis reactions. A metathesis reactions occur when two ionic aqueous solutions are mixed and the ions switch partners. For example, in a reaction of AX plus BY to form AY and BX, we can see that A and B have exchanged their places. So this is a metathesis or a double displacement reaction. Metathesis reactions remove ions from solution in two ways. They form predominantly unionized molecules like water, or they form an insoluble solid. Ion removal is the driving force of these reactions. The first type of metathesis reaction that we will look at will be a precipitation reaction. In a precipitation reaction, an insoluble compound is formed, a solid, a precipitate. To be able to predict what our product is, we will need to know the solubility rules again. They are shown on this slide. Very quickly, all nitrates are soluble, all acetates are soluble, all halides are soluble except for silver, lead 2, and mercury 1. All sulfates are soluble except for calcium, strontium, barium, mercury 1, and lead 2. All alkali metals or ammonium ion salts are soluble. And then we have a class that are mostly insoluble. For the hydroxides, carbonates, and phosphates, all of these are insoluble except for the alkali metals or the ammonium ion. An example of a precipitation reaction is the reaction of aqueous calcium nitrate with aqueous potassium carbonate, and the products that switching ions are aqueous potassium nitrate and solid calcium carbonate. We know based on our solubility rules that calcium carbonate is insoluble, therefore it will be our precipitate. We've just gone over our molecular unit equation, and now how do we go to our total ionic equation? Calcium nitrate, all nitrates are soluble, so this would exist as aqueous calcium ions and aqueous nitrate ions. Potassium carbonate, all group 1 salts are soluble, so this would exist as aqueous potassium ions and aqueous carbonate ions. All nitrates are soluble, so potassium nitrate would exist as aqueous potassium ions and aqueous nitrate ions. And then we have our solid calcium carbonate. When we remove our spectator ions, the nitrate ions and the potassium ions, we end up with our net ionic equation. Aqueous calcium ions reacting with aqueous carbonate ions to form solid calcium carbonate. Again, in this reaction, the solid calcium carbonate was formed as a precipitate. All carbonates are insoluble with the exception of alkali metals and the ammonium salts. So calcium carbonate is a solid. Our next class of metathesis reactions are neutralization reactions. Neutralization reactions are where an acid and a base reacts to form a salt and water. In these 4 examples we have on this slide, we can see that the acids shown on the left swap the cations with the base shown on the left second row to form salts and liquid water. In this example, the sodium chloride, the potassium bromide, the potassium sulfate, and calcium sulfate are all salts. So when we look at the 3 equations for this neutralization reaction, we can see that aqueous hydrobromic acid reacts with aqueous potassium hydroxide to form aqueous potassium bromide and liquid water. When we convert to the total ionic equation, the strong acid hydrobromic acid exists as aqueous potassium. The strong acid, hydrobromic acid, exists as aqueous hydrogen ions and aqueous bromide ions. The strong base, potassium hydroxide, exists as aqueous potassium ions and aqueous hydroxide ions. The salt, potassium bromide, all group 1 salts are soluble, so this would exist as aqueous potassium ions and aqueous bromide ions. And then we have liquid water. When we remove the spectator ions, the potassium and bromide ion, we end up with our net ionic equation. Aqueous hydrogen ions react with aqueous hydroxide ions to form liquid water. Another example, in this example we have the weak acid, acetic acid, reacting with aqueous sodium hydroxide to form aqueous sodium acetate and liquid water. Acetic acid is a weak acid, so it's written in the molecular form, so aqueous acetic acid. The strong base sodium hydroxide would exist as aqueous sodium ions and aqueous hydroxide ions. All acetates are soluble, so sodium acetate would exist as aqueous acetate and aqueous sodium ions. And then we have liquid water. When we remove our spectator ions, we end up with aqueous acetic acid, aqueous hydroxide ion, reacts to form liquid water and aqueous acetate ions. So these are two distinct classes of metathesis reactions, the precipitation reaction and the neutralization reactions. We've seen how to write the formula unit or molecular unit equation, the total ionic equation, and the net ionic equation. We hope that this discussion has helped you understand metathesis reactions. Thank you for listening to this episode of Georgia Highlands College Chemistry Podcast. We hope this episode has helped spark some interest and excitement in chemistry. We look forward to sharing more chemistry podcasts with you in the future.